Welcome back to Passing the Security Plus exam. This is Dr. Aisha, your instructor. Now, week 3, we're going to talk more about secure communications and authentication. We shift into this most critical part of cybersecurity, secure communication and authentication. Everything that we do in cybersecurity comes down to this. How do we protect our data? How do we verify identity? This week, you'll understand how modern security actually works. Section 1 is about encryption basics. Start here with the foundation, which is encryption. Here are some core concepts. Turning readable data, called plain text, into unreadable data, called ciphertext. Decryption is when you turn back encrypted data into readable form. Cipher is the actual algorithm that performs this transformation. Think of encryption like a lock. The cipher is the locking mechanism. The key to the lock is how you open it. The key is what controls the encryption and decryption process. Ask the question on the exam, what makes encryption secure? The answer usually is key management, not the algorithm itself. Talk more about this encryption. And let's break it down into encryption types in section 2, types of encryption. There are 2 major types. Symmetric encryption uses one shared key. It's fast and it's efficient. It is mostly used for bulk data encryption. Asymmetric encryption is the next type. It uses 2 keys. A public key to encrypt and a private key to decrypt. Asymmetric encryption solves the key distribution problem. However, the weakness is it's slower than the symmetric encryption. In the real world, both are used together. Asymmetric to exchange the keys and symmetric to encrypt the data. For the exam, you may see what's the fastest encryption? Symmetric. What's the secure key exchange? Asymmetric. Section 3, hashing and digital signatures. Sometimes where students can get a little confused, so let's slow it down just a little bit. Hashing is a one-way process, okay? So it converts data into fixed length value, okay? And it cannot be reversed. So you'll use this for password hashing and a password storage, also for integrity checks. When you see hashing on the exam, another key thing is it will always go with integrity. Hashing equals integrity because you know that the data has not been compromised. Even if one character changes, the hashing will change completely. Digital signatures. The way to explain a digital signature is through your email, right? This is use of your private key to sign data through email exchange, right? So this provides authentication that we know who the user is, integrity that the person cannot deny or anything of the actual email being sent, the information. That is called non-repudiation, that you cannot deny. It means that you cannot deny sending something to a particular user through your digital signature. You can also think about the digital signatures on the document. If you work for the government or the military and you have a CAT card, you use digital signatures to sign a document. And that's a way to validate and verify that it is you, the actual sender, through your digital signature. So an exam tip, remember, hashing equals integrity. Digital signature equals identity, integrity, and non-repudiation. Section 4, PKI. That is your public key infrastructure. This is also going to be a huge exam topic. What is PKI? PKI is the system that manages the keys, certificates, and trust. Components of PKI are certificate authority, your CA. That is when a trusted entity that issues certificates to particular users, systems, applications, stuff like that. Your digital certificate that provides identity and binds to the public key. Now let's talk about the chain of trust. Think of this like a hierarchy. CA to the intermediate CA to the end user certification. If you trust the root, you have to trust everything below. Now let's talk about certificate revocation. What if a certificate is compromised? The CRL certificate revocation lists invalid certificates. Here's another exam tip. If you see trusted third party, that equals CA. If you see a list of revoked certificates, certs or certificates, that is your CRL. Section 5, secure protocols. Let's apply everything that we've just learned. HTTPS is your secure version of HTTP. HTTPS uses TLS, protects web traffic. TLS, transport layer security, encrypts data in transit while it's moving, provides confidentiality, integrity, and availability. SSH provides secure remote access, replaces the telnet. SFTP, this is where secure files transfer over SSH. Another quick exam tip. HTTPS equals web security. SSH equals secure remote login. SFTP equals secure file transfer. Session 6, wireless security. Wireless networks introduce additional risks that we have to be mindful of. There's several different key technologies for wireless technology. WPA3, 3. Currently, this is the strongest Wi-Fi encryption standard. EAP is the authentication framework. Radius is a centralized authentication server. Enterprise environments, EAP plus Radius work together for secure authentication. Section 7, authentication methods. Now let's talk about verifying identity. There's several different authentication factors. Let's talk about multi-factor authentication, and let's break it down into 4 different areas, okay? Something you know, like your password. Something you have, like a token, cat card pin. Something you are, your biometrics, your retina, your facial scans. Multi-factor authentication is a combination of those factors, 2 or more. So your password plus your phone code. SSO, single sign-on, one log-on into multiple systems. But it must be secured properly. Here's another exam question. The best way to prevent unauthorized access is through multi-factor authentication. Now let's have some closing and some key takeaways. Encryption protects data confidentiality, and phishing ensures integrity. Remember, hashing equals integrity. PKI establishes trust, and secure protocols protect data in transit. Authentication controls who gets access. If you can answer these 3 questions, you're ready, more ready than you think. How is the data protected? How is identity verified? Who do we trust? Well, we're going to talk more about this in class tonight. So I can't wait to see you there.